Hello everyone, I Priyanka Sharma, Assistant Professor, Department of Computer Science, University of Science and Technology, Meghalaya. Going to discuss today's topic on construction of deterministic finite automata, that means construction of DFA, lecture 2. Already we have discussed in our lecture 1 the formal definition, the basic terminologies of DFA, the formal definition of finite automata, the concept of clean star and clean closure, and the basic the terminologies used in case of deterministic finite automata. So before going to start the construction part, construction of DFA, so let me explain again the formal definition of DFA. So DFA can be represented by 5 tuple, and 5 tuple consists of capital Q, sigma, delta, Q naught and capital F, where capital Q is a finite set of states and sigma is a finite set of input symbols called the alphabet. Delta is a transition function where delta maps Q, capital Q into sigma tends to capital Q. Q naught is a initial state from where any input is processed, and Q naught is also a subset of capital Q. Capital F is a set of final state, and capital F is also a subset of capital Q. So this is the formal definition of DFA. Now the basic problems of construction of DFA, we are divided this problem into two different types, type 1 and type 2. So type 2 problem, we will discuss the construction of deterministic finite automata for languages consisting of string ending with a particular substring. Now here is a steps to construct the deterministic finite automata. Now step 1, first we have to determine the minimum number of states required in DFA. After determining the minimum number of states, next we have to draw those states. Now already we have discussed that states can be represented by a circle and transition can be represented by arrow. So use the following rules to determine the minimum number of states. We have to follow, that means, few rules. So rule number 1, first we have to calculate the length of the substring. Then all strings ending with, suppose, n length substring. Then we need n plus 1 states to construct the required DFA. Suppose n is given 3, that means 3 is the length of the substring, given substring. Then 3 plus 1, 4 states required to construct the DFA for that particular string. Now step number 2, decide the string for which DFA will be constructed. After that, construct the DFA for the string decided in step number 2. Then send all the left possible combinations to the string starting state, and do not send the left possible combination over the date state. Now what is date state? Date state means here the state from which we cannot reach to the final state, but from the initial state we can reach to the date state, but from that state, from date state, we cannot reach to the final state. Fine. So date state here is basically behaves like dustbin. That means we can send input from the initial state to the date state, but from that date state we cannot move forward to the final state. So this is the concept of dead state here. Now let's move to the practice problem based on the construction of DFA type 1 problem. So problem number 1, here you see question is given, draw a DFA for the language accepting string ending with 0, 1 over input alphabet 0, 1. So here the given string is given, that means 0, 1 is a given string. That means first what we have to do, we have to calculate the length of the given string. So 0, 1 is a given string, that means length of this given string is 2. That means how much states required to construct the DFA? 2 plus 1, that means 3 states required to construct the DFA. Now here in the solution, regular expression is also given. Now what is regular expression? Regular expression is basically, it is a collection of strings, and this is basically helps to design a particular language, and here in this case it helps to design regular language and which can be accepted by a regular grammar or the deterministic finite automata machine. Fine. So here according to question, draw a DFA for the language accepting string ending with 0, 1. That means the ending string should be the constant one. But doesn't matter, before 0, 1, whatever string may appear, it doesn't matter. So we are giving here 0 plus 1 whole star. 0 plus 1 whole star means it represents, basically star represents the clean star, and definition of clean star is what? It is a collection of all possible strings over input alphabet 0, 1 including the empty string. So this is a regular expression for the given problem. Now next what we have to do, we have to identify the string. Now based on that string 0, 1, 0, 0, 1, 0, 1, 0, 1, we are going to design the machines. Fine. So step number 3, we are going to design the machines. So we need what? We need only the 3 states to draw the machine. Q0, Q1, Q2 are the 3 states. Now Q0 state is basically, it can move, Q0 state can move to Q1 state after accepting input alphabet 0. And after accepting input alphabet 1, Q0 can remain in its own state. Similarly, Q1 can move to its next state Q2 after accepting 1. Similarly, Q1 can remain in its own state after accepting 0. Q2 here is the final state. It is represented by the double circle. So after accepting 0, Q2 can move from Q2 to Q1 state. Similarly, after accepting 1, Q2 can move from Q2 to Q0 state. So this is a transition diagram for the given problem. Now this transition diagram is valid or not, we have to check based on this string. Now this diagram will accept 0, 1 string or not, we have to check. So given string is 0, 1. So now 0, 1 this diagram can accept or not. So Q0 state, so we have to start from the initial state Q0 state. So first symbol is 0, so Q0 can accept 0 symbol and it can move from Q0 to Q1 state. Next symbol is what? 1. That means Q1 can also accept 1 symbol and can move from Q1 to Q2. That means we can say that this machine can accept 0, 1 string. Similarly, this machine can accept 0, 0, 1 or not, that we have to check. So first symbol is 0. So yes, Q0 can accept 0 and can move from Q0 to Q1. Next symbol is again 0. That means Q1 can accept 0 from its self loop and remain in its own state. And next symbol what we need, again 1. So Q1 can accept 1 and can move from Q1 to Q2. That means this machine can accept 0, 001 string, and for this string machine is correct. Similarly 0101, this machine can accept 0101 or not. First symbol is 0, that means Q0 can accept 0 and can move from Q0 to Q1. Next symbol is 1, so Q1 can accept 1 and can move from Q1 to Q2. Next symbol is again 0, so Q2 can accept 0 and can move to the Q1 state. And third symbol is again 0, so Q2 can accept 0 and can move to Q1 state. And last symbol is 1, that means Q2 can take 1 or accept 1 and move to the Q0 state. That means this machine is true for the string 0101. So let's move to the problem number 2. Draw a DFA for the language accepting string ending with ABB. Now string is ending with ABB, that means the ending string is constant, but it doesn't matter what appear before ABB. That's why I'm giving A or B whole star, that is clean star, and this is the regular expression for the given languages. Now step number 1 is what? All string of the language ends with substring ABB, that means the length of the substring is 3. That means the minimum number of states required in DFA equal to 3 plus 1, 4, and it suggests that minimized DFA will have 4 states. Now move to the step number 2. Then here we have to identify the strings. So here these are the strings, and based on that string we are going to construct the DFA. Now this DFA will accept this string or not, that we have to be identified. So first Q0 state can move to its Q1 state after accepting input alphabet 1 A. Similarly, after accepting input alphabet B, Q0 can remain in its own state, and Q1 can move to its next state after accepting input alphabet B, and Q1 can remain in its own state after accepting input alphabet A. Similarly, Q2 can move to its next state, that is Q3, after accepting input alphabet B, and Q2 can move back to Q1 after accepting input alphabet A. Similarly, Q3 can move to Q1 after accepting A, and it can move to Q0 after accepting B. So this is the overall or diagram or DFA for the given string. Now this DFA is holds good or not for this particular string. So we have to check. Now first string is ABB. So this machine can accept ABB or not. So start from the Q0 state. So Q0 can accept the first symbol A and can move to its next step. So next symbol is what? Again B. So Q1 can accept B and can move to its next state. Now from this Q2 state, again Q2 can accept B and move to its last state, that means the Q3 state. That means this machine can accept ABB. Now similarly, this machine can accept AABB or not. So first symbol is A. So Q0 can accept A and can move from Q0 to Q1. Similarly, Q1 can accept A from its own self loop and it can remain in its own state. Similarly, Q2 can accept also, next symbol is what? Next symbol is again B. So now Q2 can accept B and can move to its next state. And last symbol is again B. So from B, Q2 can accept B and can move to its last state. That means this machine can accept A, B, B. Similarly, A, B, A, B, B, this string machine can accept or not, that we have to check. So first symbol is A. So Q0 can accept A and can move to its next state Q1. Next symbol is B. So Q1 can accept B and move to its next state. Next symbol is A. So from Q2, we can accept A and move to the Q1 state. Then again B. So Q1 can accept B and move to the next state Q2. And again we need B. So Q2 can accept B and move to the last state Q3. So we can say that this machine can accept A, B, B string. So till now machine is correct. So last string is what? A, B, B, A, B, B. Now this machine can accept A, B, B, A, B, B or not. So first symbol is what? A. So Q0 can accept A and can move to its next state Q1. Next symbol is B. So Q1 from this Q1 can accept B and can move to its next state. Next symbol is again B. So Q2 can accept B and move to its next state Q3. Now next symbol we need A. So from Q3 we have to follow this path. That means Q3 can accept A and can move to Q1. And again we need B. So from Q1, Q1 can accept B and can move to its next state Q2. Now last symbol what we need, again B. So Q2 can accept B and move to its final state. That means we can say that this machine can accept the last string A, B, B, A, B, B. So this machine is true for all these strings. So similarly we can check for any string that string ending with ABB, and then we can check the validity of the machine also. Now this is the final diagram or the required DFA for the given questions. Now problem number 3 is also given. So problem number 3, here you see, draw a DFA for the language accepting string ending with A, B, B, A over input alphabet sigma A, B. Here the solution is given. So regular expression is given. So here the string ending with A, B, B, A means the given string is of length 4. That means how many number of states required? So we need 4 plus 1, that means 5 states required to construct the DFA. Now what would be the regular expression? So since the string ending with A, B, B, A, that means the last string is constant, the last substring is constant, but it doesn't matter what appear before A, B, B, A. Therefore, I am using here A plus B whole star A, B, B, because A, B, B is the last substring, is a constant string, but it doesn't matter what appear before A, B, B, A. That's why here I am using the clean star concept. Now to construct the required DFA, first step what we have to do, we have to calculate the length of the substring. So length of the substring is 4. That means the required number of states is equal to 4 plus 1, that is 5. Now after that we have to uh, we have to calculate, or we have to design the strings, and based on that string we are going to design the machines. Now we will construct DFA for the following string A, B, B, A, A, B, B, A, A, B, A, B, B, A, A, B, B, A, B, B, A, and A, B, B, A, B, B, A. Now for this string we are going to construct DFA, and then we will check this DFA will accept this string or not. Now the first string is ABBA. So simply place ABB over the transition. So here Q0, Q1, Q2, Q3 and Q4 are the states required to construct DFA. Now ABBA, that means Q0 can move to its next state after accepting A, and Q0 can remain in its own state after accepting B. Similarly, Q1 can move to its next state after accepting input alphabet B, and Q1 can remain in its own state after accepting input alphabet A. Similarly, Q2 can move to its next state Q3 after accepting input alphabet B, and Q2 can move to Q1 after accepting input alphabet A. Similarly, from Q3 we can move to Q4 after accepting input alphabet A, and from Q3 we can move back to Q0 after accepting input alphabet B. Similarly, for Q4 state or the final state, we can move from Q4 to Q2 after accepting input alphabet B, and we can move from Q4 to Q1 after accepting input alphabet A. Now, this is the final diagram or required diagram for the given question. Now, this diagram will accept this particular string or not. That thing we are going to check. Now, first string is ABBA. Now, this machine can accept this string or not. So, first symbol of this string is A. So, Q0, so we have to start from the initial state again. Q0 is the initial state. So, Q0 can accept input string A, and it can move to its next state Q1. Now, next symbol we need B. So, Q1 can accept B and can move to its next state Q2. Next symbol we need again B. So, from Q2, Q2 can accept B and can move forward, and it will reach Q3 state. Next symbol what we need? Again A we need. So Q3 can accept A and move forward to Q4, and Q4 is the final state. That means we can say that this machine can accept ABBA string. Similarly, next string is AABBA. So this machine can accept AABBA or not. We have to check. So first string is what? First string is A. So machine Q0 state can accept A and can move to its next state. Similarly, next symbol is again A. So Q0 can accept A and can remain in its own state. Next symbol we need B. That means from Q1, Q1 can accept B and can move forward. Similarly, next symbol we need again B. So Q2 can accept B and can move forward to Q3. Next symbol we need A. So Q3 can accept A, can move to the last state Q4. So Q4 is the acceptance state. That means we can say that this machine can accept AABBA string. Similarly, we can check for ABABBA, and we can also check for ABBA. So let's check for the string ABBA. Now here you see ABBA. So first symbol is A. So Q0 can accept A and can move to its next state Q1. Next symbol is double B. So first B we can accept from Q1 state and can move to the Q2 state. And from Q2 state, next B we can accept and can move to the next state Q3. Then next symbol what we need? A. Again we need A. So from Q3 can accept A and move to the next state Q4. Next symbol we need double B. So from Q4 we can accept B and we can move to Q4 to Q2. And next symbol again we need B. So from Q2 again we can move forward and accept B and we can reach to Q3 state. And last symbol what we need A last, and for A we can accept Q3. Q3 state can accept A and can move from Q3 to Q4. So Q4 is a final state. That means this machine can accept A, BB, A, BB, A string. So this machine is correct for all the string, all this testing string. That means we can say that this is the required DFA for the given question. Similarly, you can check for any string ending with A, B, B, A, and you can check for this machine, and this machine will work or not. That thing also you can check. That means here in this lecture we are basically discussed about the DFA, basic formula or basic definition of DFA, how to construct a deterministic finite automata for a given string ending with a particular substring. We have discussed, and our next lecture we will discuss type 2 problem. So type 2 problem is basically the problem where we will discuss the construction of DFA for the language consisting of string starting with a particular substring. So we will discuss in our next lecture. So till now, thank you so much.